All right. So in this module, I want to talk about extrinsic defects and their reactions. So an extrinsic, as the name implies, right, the extrinsic means it comes from outside of the component. And so these are defects added from external sources. So the so just kind of why we care about this, right? Electrical and optical properties of some of these extrinsically doped ceramics tends to dominate even small amounts of these dopants. So, just kind of an aside here, when we talk about external things, they can either be put there purposefully, in which we call them a dopant. So they're purposely added. Or you might also hear it as an impurity. And this is when they're not purposefully put in. So impurities are just things that are difficult to remove because it's very difficult to have a pure material. So sometimes you hear dopant or doping. Sometimes you hear about impurities, but we're really talking about the same thing. It's just whether we do it on purpose. Like in semiconductors, we add things purposefully to affect the properties, whereas a pure material often has impurities from the way that it's mined or processed, and so those are not purposeful, but they're still there. So most for making these defect reactions, the purpose doesn't really matter, but the name can be slightly different. Okay, so when we talk about doping or impurities, the dopant ions tend to substitute for the host ion, and they tend to substitute the host ion with the closest chemical structure or electronegativity. Electronegativity, not necessarily closest size. So it usually is dealing with size, but not necessarily the only consideration. We also want to consider electronegativity. So this means cations for cations and anions for anions, and then this is less so for covalent materials. So when we write the reactions for these extrinsic defect reactions, there's often multiple ways to balance charge and so forth. And so we want to minimize the number of defects. That's kind of one of our general assumptions, that we're trying to minimize the number of defects that would that result from doping or impurities. So again, there's numerous ways that we can achieve a balanced defect reaction, but we want to try to minimize the number of defects that happen. And we also have to consider things like we have before, like the structure and ionic size and level of covalency, and there are a number of other things. Also, there's some things that we just can't know without doing experiments, right? Without kind of running an experiment and seeing what type of defects result. So there's often multiple options with these types of reactions. All right, So in the next module, we're going to go through an example of one of these extrinsic defect reactions for this material.